recording, and again, like I said, we're going to be talking about matrix inverses. If I share my screen with you, I just want to point out in our Canvas class, okay, we're in week 3. Hopefully everybody's seeing Canvas. Okay, I am going through these notes. Okay, so today we're doing matrix inverse notes. If you want to look at those, or some of you said you like to print them off and write in them yourself. Okay, just so you know, again, it's probably a good idea to try to actually participate in whatever discussion we have. And I know it's hard in this environment, rather than to take frantic notes, because everything I write down, I'm going to share with you. Remember, that'll be here in live online sessions. Okay, you're going to have a link to the video that I'm currently recording here, and then the files that I'm working on will be here in files shared. Okay, so I just wanted to make sure everybody's comfortable with, where I'm getting the information from, because some of you have asked me, hey, what are you sharing? Can I print that in advance? Okay, so with any luck, I will be able to share my iPad with you. And I want to talk a little bit about what do I mean by inverses, okay? And before we talk about that, we kind of have to talk about what I mean by identities, okay? So let me do that first. Okay, and let me see if I can share that with you. Okay, so share content. And okay, so hopefully everybody is seeing, okay, a page in my notes. And again, what I will do is bring open the chat in case you've got any questions while we're moving along, okay? So what I've got going on here is a little discussion about inverses and identities. Now, you might not have ever heard of these terms before, and that's okay. They've done an attempt to, over the last couple of decades in at least elementary school, they've tried to simplify these concepts so it's easier for younger students to remember. But if you've got any kind of an operation in mathematics, whether it's on numbers or whether it's on matrices, it probably has an identity element, and it has the concept of an inverse operation, okay? Inverse operations you're already pretty familiar with. It's what you use when you do algebra, okay? And we'll talk about that in a minute. But let's just talk about the operations you're familiar with numbers, okay? So if we're talking about multiplication, for example, its identity element is 1, okay? And what does that mean? That means if you take any number and you multiply it by 1, you get the any number back, right? And it doesn't matter if that number is a negative number. It doesn't matter if it's a fraction. Okay, that's the concept of an identity. Multiply, if you use the operation, okay, and you multiply by that identity, because my operations multiply, I'm going to get the other number back again. Okay, I can hear you all saying duh. Okay, and that's good. All right, it's similar, it's simple, and it's familiar. Okay, now what about the idea of an inverse? Okay, you know this from algebra. We don't typically call a multiplicative inverse a multiplicative inverse. We call it a reciprocal. Okay, so most students, when they first meet multiplicative inverses, they call them reciprocals. And what does that mean? Well, say I have 3 and I multiply it by its multiplicative inverse. Okay, that's 1/3, right? Everybody remember I can write 3 as 3 over 1. Okay, and then the reciprocal is just flipping the numerator and denominator. Well, you can see when I multiply this out, I get 3/3, which is 1. Okay, and that's the identity for multiplication. So the idea is if you take a number and you multiply it by its multiplicative inverse, you get the identity. Okay, so again, strategy is here's the inverse. Okay, here's the identity. All right, that's a pattern you're going to see over and over and over again. Okay, let's talk about addition. Okay, addition has an identity element, it's 0. Okay, and what that means is if you take any number and you add the identity element to it, you get the other number. Okay, same with a negative number. Add the identity, I get that other number back again. Okay, so the identity for addition works in a similar way for the identity for multiplication. It's just the operation's different, right? Well, let's talk about an additive inverse. Okay, they don't call them that anymore. They call them opposites. Okay, and you know that if you take any number and you add its opposite, you get, guess what? The identity element for addition. Okay, so here's the additive inverse, and this is the identity. Okay, now again, probably nobody ever showed you this. And again, I'm sorry about that. It's a pretty fundamental thing about not just numbers, but relationships in mathematics. So let's talk about matrix multiplication. And again, I probably should have said matrix multiplication. Okay, we have the concept of an identity, and guess what? It's a matrix. Okay, an identity is usually a square matrix, and it has ones on the diagonal and zeros everywhere else. So it looks like it's in reduced row echelon form like this. Okay, this is a 2 by 2 identity matrix, and it's usually given a special letter name, I2. Okay, for those of you who have a TI-84 calculator, it has the ability to generate I2, I3, I4. Okay, I can show you where those are. Okay, so here's I3. Okay, it's an identity matrix with ones on the diagonal and zeros everywhere else. Okay, now based on what we saw, okay, before with numbers, with multiplying and adding, we know if I take a matrix and I multiply it by its inverse, whatever that is, that's what we're going to learn today, okay, then I should get the identity, right? Just like I did up here. Okay, so I'm going to call the inverse of, let's say I have matrix A, then I'm going to call A inverse. Okay, I'm writing it with this little -1 as the superscript. That's not an exponent, although you could think of it like that. It means inverse. Okay, where does that come from? It comes from the idea that if I take 2 and I raise it to the -1 power, I get 1/2. Okay, so I get the multiplicative inverse that way. Okay, but if I do this then, if I multiply a matrix by its inverse with matrix multiplication, I should get the identity matrix. Okay? And here's the inverse. Okay, I kind of wanted to give you this overview first. Otherwise, it seems like all we're doing is this mechanical matrixy stuff, and we really don't know why we're doing it. Okay? Again, I want to make sure you're okay with this. Again, remember I told you that this equation, this thing I have right here, okay, is actually an equation in something called linear algebra. The things that are in that equation are variables, but they represent matrices, not just a single number. Okay, so I'll say linear algebra equation. Right? And part of what we're learning today will allow you to solve linear algebra equations, okay? Because they show up a lot in business. They show up especially in statistics, although they also show up in the things that have to do with production, okay? And being able to estimate production, okay? I don't know if you've ever heard of Leon-Tiff matrices, but they're used in a somewhat centrally planned economy to determine how much production is necessary to meet not only the requirements of production, but any external demands on the system. Okay, with any luck, we'll get to talk about those as applications. But let me stop over here and let me ask, is everybody okay with inverses and identities, the concepts? Everybody okay with inverses and identities before we move on? Okay. Any questions at all? Okay. All right, so now I'm going to move into the notes. And again, remember, we're going to learn how to do this sort of by hand, but we're not going to really do it by hand when we need to do a lot of it or we need to solve a problem. We're going to use Symbolab. We're going to use the TI-84. And I will show you how to do these inverses on Symbolab and on the TI-84. So please don't think, oh my gosh, this is going to be taking me forever. I would urge you to try some of them by hand. But again, remember, you have the software, you have the technology as a backup, okay? So there's no need to do everything by hand, okay? So again, we're starting out with identity matrices, okay? And again, they have ones on the diagonal. Here you can see I2, and here's I3, okay? Which again, are those identity matrices. You would expect by definition, okay, if I take an identity matrix like I2 and I multiply some other matrix by it, now it has to be the right size. So how about a 2 by 2 matrix like this? Right? Everybody realizes the dimensions on this are 2 by 2, these are 2 by 2. So the multiplication's possible, okay? So what do you think I should get when I multiply these? Okay, without actually doing it, what should the answer be for the product? Right, okay, itself. Okay, so I should get matrix A back again, right? Matrix A, I should get back. And again, if you were to actually multiply this out by hand, you would see you get 2 minus 4 minus 1. Okay, so what this says, this linear algebra equation I have down here says if you multiply a matrix by an identity, you get the matrix back again. Okay, so let's actually try it. Now, one cool thing about the identity matrix, you'll notice I put it on the left here. Here they're putting it on the right. Again, as long as the dimensions work, okay, you should be able to multiply by the identity on either side of your matrix. Remember, we said matrix multiplication is not commutative, but it is with the identity. Okay, that's like an exception. Okay, so again, if I were to do this, you can see I should get a 2 by 2 result. And in order to do the multiply, I need to go across that row and then down that column, okay, to put my result over here. So that would be 4 times 1 plus 5 times 0. That goes there. All right. And again, I can go across that row and then down the other column, and that result should go over here where the row and the column intersect. So that would give me 4 times 0 plus 5 times 1. Okay, and now I can move down a row. And again, I promise I won't do this with every single matrix, okay? But I just want to show people what's going on so they're not confused. Now I'm going to go across the bottom row and down the first column. So that gives me 6 times 1 plus 7 times 0. And last but not least, I'll go across the bottom row and down this last column. And that will give me 6 times 0 plus 7 times 1. Okay, using, again, matrix multiplication. Since a lot of these entities are multiplied by 0, you can see here, okay, this is going to give me 4, 5, 6, 7, which again is the matrix I started with. Okay. Now, I would like to show you again how to do this in, say, Symbolab. And again, I'm hoping Symbolab has an identity type situation where I can say identity 2 or identity 3. So I'm going to try this thing. Again, look at this matrix. It's 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's easy to remember. Okay, and again, here's the I3 identity matrix. Okay, both of these are 3 by 3 matrices. And we know in advance that we should get the starting matrix back again. But let's go to Symbolab. Okay, I should already be sharing my browser with you, so hopefully Symbolab will come up. Okay, so is everybody seeing Symbolab? Okay, if somebody could just shout out, yes. Okay, good. All right. So I'm hoping they have an identity. Okay, identity 2, maybe. Or do I have to build it? Okay, identity matrix, let's see. Nope, it looks like I'm stuck building it. Okay, so they're identities, but they're trig identities, right? So I'm going to build a 3 by 3 matrix with those values in it, okay? And they were 2, 3, 4, so I'm just tabbing over. Okay, so that's my first matrix. I need another 3 by 3, and this one's easy. It's just ones and zeros. Okay, so I'm doing the same multiplication operation. I hit go. All right, and you should get that same matrix back again. All right, so just slide on down, and you can see right here, you've got the same matrix back. Okay, it would have been nice if they had a built-in identity feature, okay, like a TI-84 has, but basically, it's not a big deal to type in an identity matrix. Just make sure you put the ones and zeros in the correct place. Okay, so I'm going to head back onto the notes. All right, and we can just put our answer in over here. Okay, and again, the important thing is realize you get the starting matrix back again. Okay. If I scroll down over here, let's take a look at these two matrices. You see I have a 2 by 2 identity matrix. Okay, and again, the second matrix isn't square, okay, but it is something I can multiply by because those inner dimensions match, okay? The difference is I should get a 2 by 3 matrix, which you'd expect, because this is a 2 by 3 matrix, right? And you're expecting to get the same thing back again, okay? And it turns out that you can do this as long as you pick an identity matrix that will allow this operation to proceed, okay? You'll get 3, 8, -5, -2, okay? So again, they don't have to be square matrices in order for you to use the identity matrix. You just have to pick the right dimension identity matrix that the multiplication can proceed. Okay, and here you get a 2 by 3. Okay, everybody remember, here's the dimensions of the product matrix. Okay, that's important to remember. So you can see, similar to what we learned about with numbers, and if I multiply the identity matrix by another matrix, the result is, well, the other matrix. All right, everybody okay with this so far? Okay. Anybody want to see it on the TI-84? Okay, I know some of you have TI-84s. Anybody want to see how to do it? Okay. All right, let me bring up the TI then. Okay, so I have to share that separately. Emulator, here we are. Hopefully you can all see the TI. And again, if you put in a matrix, you remember you go to second, and here's an inverse key. This key will turn out to be very important, okay, when we do inverses, okay? But for now, I'm just gonna put a matrix in here, okay? So I have to go over to edit, and then I'm gonna select the first one. First thing I have to do is give it dimensions. So let me make it a 3 by 3. And I'll do that 2, 3, 4, 1, 2, 3, 4. Oops. It's got to be a little different on here. Sorry. Okay, so here's my matrix with the numbers in it. Okay, I'm going to quit out of here. And let me get into matrix again and see if I have math. Okay. See identity number 5. Okay. Identity number 5 is basically building an identity. Okay. So I have my matrix in A. Okay. And I can use this to build an identity. So let me do this first because I'm here. I'm going to select identity. I had a 3 by 3 matrix, so I need a 3 by 3 identity. I'm just going to dump it so you can see what it looks like. Here's my 3 by 3 identity matrix. Okay, so let me get that back in here again. I'm going to do that by saying second, enter. And now what I want to do is I want to multiply that by matrix A. So second matrix, and I'm pulling A out of the names list. All right. And if I do this operation, I should get matrix A back again. And there it is. Okay. Okay, so everybody okay with it on the TI? Okay, I want you to use whatever it is you're comfortable using. Okay. Symbolab works, so does TI. All right. Okay. Well, moving on. Okay, let's go back to inverses then. Okay, we kind of said that with numbers, a multiplicative inverse kind of undoes the operation of multiplying and gives you the multiplicative identity one back. Same thing with an additive inverse. If I add 0, right, our additive inverse to any number, I get the identity. I get the thing back again. Okay, so here's kind of what they're showing you here. A matrix is an inverse of another matrix if their product results in an identity. So this is exactly like what we did, okay, for example, with numbers. Instead of matrices, right? Okay, instead of a multiplicative, instead of the matrix inverse, if I had a reciprocal times the original number, that gives me the identity for multiplication, right? Everybody see the parallel here, okay? It's the same thing. If I took an additive inverse, like a -2, and I added it to +2, I get the identity 0 for addition. Okay, so the same idea. Okay, so this is really important to remember. Okay, it's helpful when you're actually trying to deal with those linear algebra equations. Okay, so how do we find the inverse of a matrix? Okay, we're going to do it in a by hand mechanical way, but again, the tool for finding an inverse exists on the TI and it exists in Symbolab, so not to worry. Okay, remember, these methods that I'm showing you were developed long before, and I mean like centuries before we had graphing calculators. Okay, and if you want to think of them, they're sort of like what you might remember the quadratic formula being like. What is it? It's a way to unravel the coefficients in a quadratic equation to figure out what the x values are. Okay, so there are some formulas that show you how to build an inverse of a matrix. Okay, and it shows you the way the different numbers in the matrix are related to each other. Okay, so here's an example with a 2 by 2 matrix. Okay, 2 by 2 matrices are pretty easy. Okay, if you want to build an inverse, there's a pretty straightforward formula. Okay, if you call the entries in your matrix A, B, C, and D, the first thing you have to do is switch the A and D, switch the B and C, and flip their signs, and then multiply by this scalar out here. Okay, and again, this formula only works for 2 by 2 matrices. Okay, and what's that formula? Well, it's 1 over the product of the diagonals, okay, subtracted from each other. Okay, and it works as long as that number isn't 0. Okay, otherwise you wind up dividing by 0, right? All right, so this should tell you that not every matrix has an inverse, because sometimes the diagonals will wind up giving you a 0 here, all right, and you won't be able to find an inverse. Okay, so not every matrix has an inverse. So not always invertible. Here's the word, invertible. Okay, so you can't always find an inverse. Okay, but in those cases where we can, let's figure out another way to do it. Okay, now you can imagine once you get bigger than a 2 by 2, this formula gets complicated. Why? Well, bigger matrices have more diagonals. Okay, there's the main diagonal, but then there are little diagonals on either side of it. Okay, so the formula gets complicated. Okay, messy here is an understatement. Okay, so we're going to basically use our process for Gauss-Jordan elimination to try to build our inverse, knowing that if we took our original matrix and multiplied by the inverse, we'd get the identity back. Okay, so that's kind of the strategy. All right, so I'm going to walk you through the strategy. Okay, we're going to look at our matrix M, and we're going to create an augmented matrix that has M on the left side and the right size identity matrix on the other side. Well, this is a 2 by 2 matrix, so the right sized identity is 1, 0, 0, 1. Okay, that's an augmented matrix. Now the trick is going to be to use row operations, namely Gauss-Jordan elimination, to try to turn the left-hand side to be the identity. Okay, so we're going to try to make the left side equal to the identity matrix. But that's what Gauss-Jordan does anyway, right? So if I look at the left-hand side here, I'm going to try to change it into a matrix that has 1s on the diagonal and 0s everywhere else. okay? So if you remember, the first operation needs to be a multiply. I need to multiply that top row by some number that's going to make the 4 turn into a 1. Okay, what should I multiply the top row by? Yep. Okay, anybody agree with what's in the chat? Anybody have any other ideas? You might remember from our discussion of inverses and identities, if I multiply a number by its reciprocal, I get a 1. Okay, and 1 is what I'm looking for here. So I'm going to say 1/4, row 1, store it back into row 1. Now the trick here is, remember, this whole row is row 1, this whole row is row 2. Okay, so if I get fractions, I'm going to keep them as fractions. So this gives me a 1. 4 times 1/4 is 1. Okay, this is going to give me negative 1/4. This is going to give me positive 1/4, and 0 times anything is 0. Remember, the second row doesn't change at all. Okay, what do you think the second thing I should do is? I need to clear this -6. This needs to be a multiply add. Okay, so I need to multiply row 1 by a number. So when I add it to row 2, I get a 0. -6. Okay, multiply row 1 by a number so that when I add it to row 2, I get a 0, where -6 is. What should I multiply by? Okay, I'm getting a bunch of 6s. Good for you. Okay, so that's going to be 6 times row 1 plus row 2, store into row 2. Now remember, with these, I kind of try to do like a little work area. So 6 times row 1 plus row 2, store into row 2. All right, so I'm going to take everything across the top here, and I'm going to multiply it by 6. So that's a 6 minus 6/4 plus 6/4. Again, remember the 6 multiplies across in the numerator. 0 times anything is 0. I'm just copying row 2. I'm not doing anything to it. And then we add the 2 together. You can see I have 6 plus -6. That gives me the 0 I was looking for. Okay. If you think in terms of fourths, you can see that how many fourths would it take to make a 2? Okay, well, there's 4 fourths in every single one. I've got 2 of them. So 2 would be 8/4 minus 6/4. Well, that's 2/4 or 1/2. Again, feel free to do the fraction arithmetic on a calculator that will reduce the fractions for you. Okay, here I have 6/4 and a 1. Okay, so now my matrix kind of looks like this. Row 1 hasn't changed, but row 2 now looks like this. Okay, I've got a 0, a 1/2, a 0, nope, 6/4 and a 1. Okay, so the first column is taken care of. It looks like the first column of an I2 identity matrix. The next thing I should do, according to Gauss-Jordan elimination, is move over to the next column and get a 1 on the diagonal. Okay, so the next operation should be a multiply. Okay, and I need to turn the 1/2, this 1/2, okay, into a 2. Okay, so I need to multiply row 2 by what to make 1/2 a 1. Okay, so again, you're just multiplying by the reciprocal. Okay, so are you getting the hang of it that essentially to get the ones, you just do a multiply by the reciprocal. To get the zeros, you've got to multiply the row with the one in it by something that gives you the additive inverse. Okay, there you go. All right, so here we're doing a 2 times row 2 store into row 2. I think I can do that just looking at row 2. Right, row 1 isn't going to change, so that's 1, 1, 4, negative 1/4, 1/4, 0. Okay, and the second row, I'm just doubling everything, so this becomes a 1. Okay, 2 times 6/4. Okay, if you look at that, I would wind up getting this happening, 2 times 6/4. Okay, so 2 goes into 2 once, 2 goes into 4 twice, 6 divided by 2 is 3. Okay, I'm just showing you how I'm doing it. Okay, so it's not magic. Okay, and then 1 times 2 is 2. Okay, so hey, good news, got rid of the fractions in row 2. Last step is to get rid of this negative 1/4. Okay, now that has to turn into a 0. So I need to multiply this row by a number so that when I add this to that, I get a 0. Okay, again, here's where you're thinking additive inverse. What's the additive inverse of negative 1/4? What's its opposite? Anybody have any ideas? Good, Daniel. So positive 1/4, right? So now again, I'm not trying to make ones or anything. So the next step is to multiply row 2 by positive 1/4, add that to row 1, and then store it back into row 1. Again, I'm going to kind of need a little work area to help me out here. Okay, and again, multiplying by a 1/4 of row 2, that's going to give me a 0, 1/4, 3/4. And again, I can keep them like this, 2/4 or 1/2, doesn't matter. Okay, so that's multiplying that all by 1/4. Okay, everybody all right with that? Then I'm adding row 1. Okay, and again, what I wanted to happen happens right here. Okay, so now I have a 1, a 0, 3/4 and 1/4 is a 1. 2/4 and 0 is 2/4, or just 1/2. Okay, so here's my final matrix. It looks like this. Okay, I have 1, 0, 1, 1/2. And then the bottom row hasn't changed. Okay, everybody see that I got that? Now here's the deal. Here's I2. Okay, our original matrix we called M. That means this is M inverse. Okay, so I wound up with M inverse on the other side of the line. Okay, okay, with process. Now, a lot of you are looking at that and you're saying, yeah, I kind of don't believe you. How do you know that's the inverse? Well, one thing that we can decide is we can try multiplying our original matrix by its inverse, right? Our original matrix was 4, -1, -6, 2. That's M. Here's M inverse, 1, 1/2, 3, 2. And what should we get as an answer? What should the product be? What should the product be? Okay, it's not the inverse identity, it's just the identity, right? I should get I2, the identity matrix, size 2 by 2. Okay. So again, if you think about how to do that real quick, okay, that would be 4 times 1 plus negative 1 times 3. Okay. Take a look at that. 4 times 1 is 4. Negative 1 times 3 is negative 3. There's a 1 right there. Okay. And let me just go across and down here. This would be 4 times a half. Okay, going across and then down plus negative 1 times 2. Okay, half of 4 is 2. Negative 1 times 2 is negative 2. There's your 0. Okay. And then again, going across the bottom row and down the first column, negative 6 times 1 plus 2 times 3. Okay, that first product's a negative 6. The second one's positive 6. There's another 0. And this should give me a 1. Okay, so that's negative 6 times a half plus 2 times 2. Okay, so half of negative 6 is negative 3. 2 times 2 is 4. There's the 1. So I've got 1, 0, 0, which is I2. Okay, so I've just proved with this operation that, yeah, this is indeed an inverse matrix. So the original starting matrix. Okay, let's see how to do it with technology. Okay, again, I just want to make sure everybody's comfortable with the process by hand. Okay, it is possible that in some of your homework, they may give you a partially inverted matrix and might ask you for the next operation. Okay, so you need to be able to kind of get through it, at least understand what to do next, even though you can get the answer by using technology. Okay, so let me just back out. I'm back in Symbolab. Okay, I'm going to back up over this, and I'm going to put our matrix in there. It was a 2 by 2. And it was 4 tab negative 1 tab negative 6 tab 2. Okay, now that's the matrix, and what I want is its inverse. So inverse. Okay, you just type the word inverse. And you should get the matrix that we did with Gauss-Jordan. See it right here? Okay. Notice the notation. See the little -1 as the superscript? Okay, that's kind of like the linear algebra notation for invert or inverse. Okay, but here's the way you get an inverse. Okay, with inverse on Symbolab. Inverse. Everybody comfortable with it? Anybody got any questions with it? Let's show it to you on the TI, because some of you have a TI. All right, I'm going to go back to my TI. Hopefully, I'm still sharing that. You can see it. Okay, I'm going to clear my display. I want to also show you, in case I haven't already, how to get rid of matrices you don't need anymore. Okay, see above your plus sign is mem. Okay, this is your housekeeping button. Okay, so I'm going to do second plus. Okay, and it handles your memory. I'm interested in memory management delete. Okay, now I'm going to hit 2 and then enter. And these are the various things you can save on your TI-84. You can save variables. There's the little green things. Okay, you can save lists. You can save matrices. You can save things in Y bars. Okay, programs. Okay, so I want to clear out my matrices. So I'm going to go down to 5. You see, I have a matrix A that I don't need anymore. So I'm just going to hit delete. Okay. Doing it like this through memory management avoids the situation that some people get into where they get into the matrix submenu and they just start hitting the delete key. Okay, and that sometimes you wind up losing things you don't want to lose. Okay, so just go in here, do your housekeeping from here. So now I'm going to go into matrix, so second inverse. You can see no A anymore. Let me edit A. I'm going to put in a 2 by 2 matrix. Okay, fills it out with zeros, and then I'm going to put in those values, which were 4, -1, -6, and 2. Okay, so there's my matrix. I'm going to quit out of here so I don't mess it up. Okay. And then what I'm going to do is I'm just going to recall the name of that matrix from the names list. So second matrix, here it is in names. Okay. And then I'm going to use the inverse key. It's the same key we've been hitting to get into matrix after a second. You see it right here? Okay. And it just put the little -1 over here. Now, what that means is find the inverse of it. Okay. If I were to do this with a number, it would give me a reciprocal. The calculator knows this is a matrix, so it's going to give you the inverse matrix. Okay, let's take a look. And you might say, well, wait, this should have been 1/2. Well, it's 0.5. So here, if you want to see the matrix entries as fractions, don't do anything except go to math, frac. Okay, see it says ants. Ants is this matrix right now. It's the last thing the calculator typed to you. Okay, and that converts your matrix entries to fractions. Okay, everybody all right with this? Now, this has just shown it to the screen. I haven't saved this inverse anywhere. Okay, suppose I want to save the matrix inverse because I want to do stuff with it. I'm going to go back, second entry, till I get here, right? And then I'm just going to use my store key, and then I'm going to put this in another matrix in the calculator. So second inverse, let's pick matrix B. All right, so now matrix B will have the inverse to A. Everybody understand? All right. So if I multiply matrix A by matrix B, oops, wrong. Matrix A by matrix B. So that's, okay, I should get the identity matrix. You can see I do. All right. Okay, on the TI. Okay, on the TI-84. Okay. Everybody good with this? Right. Fine. Okay. All right. Back to the notes before we, let's see if I can share this. Okay, what I would like you to do is take a few minutes, all right, take a few minutes, try this one using row operations. I know you have a way to check it. Check it with Symbolab. Okay, so try it with row operations. Everybody see the one on the top of the screen here? Okay. We're going to take a few minutes and you try this one. Okay, so the very first thing you need to do is you need to build an augmented matrix that looks like this. Okay, try it. Okay, will take maybe 3 to 5 minutes. See how far you can get. It's important to be able to come up with the right Gauss-Jordan, the right row operations. Okay, that's going to be useful somewhere else. Okay, so maybe we'll get back together right around 10. Is anybody getting an answer? Okay, we got an answer. Okay. So try to type it into the chat like this. Okay, with commas between the rows. Okay, if you've got an answer, type it into the chat. Anybody else get an answer from doing row operations? Okay, if you've got an answer of an inverse matrix, type it into the chat the way I'm describing. Okay, so you put a square bracket, the first row, comma, then the second row, comma. So 7, 3, 2, 1. Good. Good, good. Okay, so here's what people are getting. And again, this is something that's easy to get on Symbolab or with the TI. Okay, so a bunch of you are getting the same thing, which is great. Okay, so let me ask, what row operations did you use? Okay, I noticed that I've already got a 1 in the first position. So I didn't need to do any multiplying to get a 1 in that first position on the diagonal. I can skip that step. So what was the first step you used? What was the first row operation? Okay, the first row operation needs to clear the 2 down here. Anybody have a suggestion? Good. Okay, so -2 times row 1, right? Because that's where the 1 is, plus row 2, store into row 2. Okay, and again, just showing those steps. Again, I'm not going to belabor this too much, but I want to make sure everybody understands where these numbers are coming from. So if I take row 1 and I double everything and then flip the signs, that's going to give me a -2, -6, -2, 0. Okay, and then add row 2, so that's 2, 7, 0, 1. Okay, this was what I wanted to go away, right? So that's a 0. That's a 1. Oh, it looks like I got something for free. Okay, so the matrix now looks like this. Row 1 hasn't changed. I've just used it. So that's 1. And row 2 is now 0, 1, -2, 1. Okay, you can tell I managed to get the 1 on the diagonal for free. Okay, so I don't need to do that next step, right? See this 1 right here? So there's only one more row operation. What's the last row operation? Okay, I need to get rid of the 3. So I need to multiply row 2 by something so that when I add it to the 3, I get a 0. Okay, good. -3 times row 2 plus row 1 store to row 1. Okay, so again, looking at those steps. Okay, multiply everything by -3 on row 2. That's a 0. -3, a 6, -3. Okay, again, negative times negative is positive. Add the row 1. 0. Okay, and here's what I wanted to go to 0 here. So I have 1, 0, 7, this should be my final matrix. Okay, so now I have 1, 0, 7, -3. Okay, and the original row 2 is 0. Okay, so here's your M. Okay, so everybody is comfortable with the process. Okay. All right. Here's just a logic question down here. How would you verify that this is indeed the inverse? Okay, remember what's that property of inverses that we can use to check? Anybody have any ideas down here? Multiply the inverse by the original, exactly. So if I were to take my original M, multiply by M inverse, I should get I2. That's how I could check. Again, it's far more important to understand answers to questions like this, okay, because we can crank through this with technology, right? So now let's get to the linear algebra part. Okay, you're probably sitting here wondering, you know, you already showed us how to RREF a matrix, so why would I need to use this? Okay, remember, this is part of a broader field called linear algebra, where you're going to actually be doing algebra on equations where the variables are matrices, okay, or vectors or something like that. It's typically definitely part of statistics, but there's other applications in business too, where you would do this, right? So anyway, it's an alternative way from using RREF to solve a system of equations. It's yet another way. And again, part of what I'm showing you is history before we had the technology. Okay. So again, alternative method for solving equations. Now you can run into problems with the method if the inverse doesn't exist. Remember I showed you that little formula where we had 1 over AD minus BC multiplying the matrix with some of the numbers switched around. If that winds up being 0, okay, that thing outside, you can't invert the matrix, okay? So if you wind up doing this, okay, you try to find an inverse and the inverse doesn't exist, the error message is called singular matrix. At least that's what it is on a TI-84. Okay, so if you get an error when you're trying to do an inverse, okay, basically it means the inverse doesn't exist. And you need to solve your system a different way, probably with RF. Okay. All right, so here's an example. I'm going to kind of walk through, you know, how we would use this. Okay, so if we wanted to solve the system, we could either build an augmented matrix with the coefficients and the right-hand sides and RREF it, but you could translate it into this form. You could have a coefficient matrix, which we're going to call A. You can have a matrix with the variables in it, which is called X. This is a vector. Remember, this is 2 by 2. This is 2 by 1. So that's allowed. Okay, and then you can have it equal the right-hand sides, which we'll call B. Okay, and so you have this equation, A times X equals B. All right, but everything in that equation is a matrix. Okay, so to solve for it, if you think about this in terms of algebra, right, you're thinking like this. Well, A X equals B. I want to get X alone. It's multiplied, so I'm going to divide to get rid of it. Okay, that's if A were a number. Okay, you could also say, I'd multiply by 1 over A. I'd multiply by its reciprocal. Okay, that's just another word for its inverse. Okay, so you're going to multiply both sides by its inverse. Like this. But it's very, very similar to what you know from algebra. okay? Again, it's unfortunate they don't use these terms when they teach algebra, okay? So this seems like it's totally foreign. Like, what are you doing? I'm doing exactly what I do when I do algebra. I multiply both sides by the multiplicative inverse. A. Okay. So if A were 3, you'd multiply both sides by 1/3, right? Well, A happens to be a matrix, so you're going to multiply by the matrix inverse. Okay. Take a look at this. Okay, everybody see what happens there? What's A inverse times A equal to? What's A inverse times A on that left-hand side? In other words, why did it disappear in the next row down? What's A inverse times A? Anybody have any ideas? Well, we did it a bunch of times. It's 1, but 1 in matrix land is identity, okay? So this would be I, okay? And I is like 1. Maybe it'd be more helpful to show you what it would look like in algebra over here, okay, with numbers, because I know this is strange, okay? So here's an algebra with numbers, okay? So let's say you started out with 3 times x equals 12, okay? So what I'm saying is this is like A, this is like X, and that's like B, okay? I'm going to take the inverse of the A part, the 3. That's the multiplicative inverse. And I'm going to multiply both sides of the equation by it, okay? So this is like A inverse. That's A, okay? These two things together give me 1, right? 1x, and that's a 4. Okay, this is the identity for multiplication. Okay, does everybody see how the pieces match? See how the pieces are similar? Okay, once you start calling one an identity and a reciprocal a multiplicative inverse, then they're the same thing. You're doing the same operation, which is good because they call this linear algebra. It should work the same way. Okay. All right. So we've translated it. Okay. And now it's just a matter of seeing how that works. Now I'm going to do it without going, I'll put the steps of the row operations in my sheet when I upload it for you, okay? But I just want to make sure you understand the linear algebra, okay? So here's the coefficient matrix, -4, 3, 3 minus 2. Everybody see where that came from, okay? So let's call this matrix A. Okay, I need you to help me out. You use Symbolab or your TI-84 and you find A inverse. Go ahead. Use Symbolab or your TI. Find A inverse. You remember how to write it? Write it like this. Okay, once you find it, type it in the chat. Okay, again, use technology. Don't do the row operations. Okay, anybody have an example, an answer for the inverse of the coefficient matrix using Symbolab? Okay, I'm getting 2, 3, 3, 4. That's what I got. Okay, so there's our inverse matrix. Okay, and again, you might remember, here's what we started with. We started with our coefficients times our variables equals our right-hand side. And what we need to do is multiply on the left this way. This much gives us the identity times x, which is just x. So if I want to know my x values, I just have to do what they say here. Multiply the inverse found in step 1 by the constant matrix. Okay? So here's what I need you to do on either Symbolab or on your TI. Here's A inverse, and here's the coefficient matrix, negative 5, 4. Okay, this is a 2 by 2. This is a 2 by 1. Okay, remember, this is going to equal x. So you're going to get x equals. Figure out what the answer is. You should get a 2 by 1 matrix. Okay, so do this multiply on Symbolab or your TI. Okay, getting some answers coming in. Let's wait for a few more people. Okay, everybody understand we're multiplying the inverse by the constant matrix. 2, 1. Okay. We've got a few people say that x is 2, 1. Okay, now remember, x was this matrix, y, xy equals. Okay, so that's telling you x is 2, y is 1. Okay, okay with the process, okay, with this example. Okay. Yes. Again, this is the important part, knowing what to do with your inverse matrix once you have it. Okay, I'm going to just slide to one last page. Okay, we're almost at the end. Here is a system of 3 equations. I want to point out the variable names. You notice how they're not x, y, z? Okay, this is pretty common when you're doing optimization problems. Okay, those little numbers that are subscripts are just telling you the first x value, the second x value, the third x value. Okay, the way you read them is x sub 1, x sub 2, x sub 3. Okay, this is a very, very common way of naming variables. Okay, rather than just giving them the names of the letters at the end of the alphabet. Okay, so I wanted to show you this example to get you somewhat familiar with the notation. And then here's what I need you to do. I want you to use technology, okay, to solve this using an inverse matrix. In other words, build a coefficient matrix. A, okay, that's going to multiply by our x's. That's going to equal our constants, which we'll call B. Okay, constant matrix. And then you solve it by doing A inverse times A. Okay, so what I need you to do is take about 5 minutes And let's see if you can get A inverse, okay, and then a solution, X. Okay, again, I'm trying to give you as little scaffolding as possible to see that you can get through the problem on your own, okay? So first let's check in, okay, and I'll ask you A inverse. I'll put that right in the chat right now to make sure we have the right inverse, okay? And then use it to solve for X, okay? Let's take 5 minutes to do that. It shouldn't take more than that. Okay, we have one potential A inverse up there in the chat. Did anybody else get that value? Again, here's your original A matrix, okay, which I just got off of the coefficients. Okay, so this came out of Symbolab, although I will show you the steps. Okay, now use it to solve for X. Okay, so we're going to multiply it by B. Okay, what's B? B is simply the coefficients. Okay, so multiply your inverse by B. You'll only be able to do it one way, okay, because of the dimensions. Let me know what you get. As soon as you get an answer, type it in the chat. Okay, you should have gotten a matrix. Remember, we're multiplying a 3 by 3 by a 3 by 1. So you should be getting a 3 by 1 matrix. Okay, there should be 3 values. Okay, 8, -4, -9. Guys, if you're getting stuck anywhere, please ask for help. You can unmute yourself and let me know where you're struggling, okay? It's just a matter of typing in the two matrices in Symbolab. So we're getting a whole bunch of people getting these answers, okay? And if you remember what X looks like X1, X2, X3. So if you want to know specifically the values, you can say X1 is 8, X2 is -4, X3 equals -9. Okay? Again, okay with the process? So this is the way, if they asked you to do it within verses, this is the way you're going to do it. You're going to leverage the technology. Okay. Again, if any of you are having trouble with the technology or are lost somewhere and you don't want to ask in the chat, that's fine. Just please email me afterwards. Okay. And we can help get you unstuck. All right. So I know there's another page to the worksheet, but you get the general idea. I'm going to stop sharing and get back to the meeting. Okay. So basically, before we end, let me just ask any questions on anything. You're also allowed to ask, when would I ever use this? Why do I have to learn another way to do this? Any of those questions, okay? Because it's very difficult to navigate your way through all of this if you don't understand why. Okay, we're all good. I'm going to stop recording.